So here's the answer key for the mini factoring review number 4. So starting with question number 1, whenever we're factoring a polynomial expression, the first thing we always need to check for is the GCF. And that's the only answer for number 1. Which then obviously sets us up to finish the factoring in questions 2A, B, C, and D. So when we approach 2A, the first thing we always need to check for is a GCF. So the number 3 and 9 have a common factor of a 3. Then I look at the variable expressions, and both of these terms have x's, so I'd be able to take x squared from both of those terms. So if I divide both terms by 3x squared, that'd help me figure out what's left in parentheses. So 3 divided by 3 is 1. X to the third divided by x squared is just x. Negative 9 divided by 3 is a negative 3. The x squareds would cancel. So this is my final answer there. Moving on to the next one, we always check for the GCF first. These do have a GCF of 3, so I'm going to write the resulting polynomial, x squared plus 2x plus 1. And again, I'm just imagining dividing all of those terms by 3. Now, just because we found the GCF doesn't mean we're done factoring, but what we do note is the polynomial that's left has a leading coefficient of 1. So I'd be asking myself what numbers would multiply to 1 and add to 2. And of course, that is positive 1 and positive 1, which you could also have written as x plus 1 squared. So either one of these would be correct, that one or that one. And the big idea here is don't forget your GCF. After you factor it out at the beginning, that's always just chilling in front of your factors. We'll move to 2C. Again, we're going to check for a GCF, but what's important here is that our leading coefficient, we want to be negative, or excuse me, we want it to be positive. It's currently negative, and we want that to be positive. So when we look for the GCF, we're going to factor out a negative 2, because after we factor out a negative 2, the thing that's left over, after we divide these by negative 2, is positive x squared plus 7x plus 12. So now that we factored out our GCF, that's going to stay out front, and it's our job to make sure that the polynomial that's left either factors more or doesn't factor more. And when I look at this, if the leading coefficient is a 1, I am able to find numbers that multiply to 12 and add to 7. So our final answer would be this. When it comes to 2D, we checked for the GCF, but there isn't one. So what I have to do from here on is I need to go and use the next method of factoring. Now with something like this, I'm not exactly sure the way that I would do it. If I want to get 4x squared, I could start that as 2x and 2x, or I could start that as 4x and 1x. So there's two options for that, but the good option is that at the end they need to multiply to a 1. So there has to only be a 1 and a 1. So I just do some guessing and checking to figure out which one of these could I possibly make into the original polynomial. So if I look at the first one, if I just use my FOIL method to check, 2x times 2x is of course 4x squared. 2x times that 1 would create some group of 2x's. Continuing my distribution, I'd get another group of 2x's, and at the end 1 times 1 would be a 1. Now my signs are missing here, but if I looked at 2x's and 2x's, there really is no way for those 2x's to ever combine to be 3x's. So what that tells me is this is not the way to do it, because if I switch the 1 and the 1, I'm going to get the same answer. So that must mean I have to go use this option, but I'm going to double check to make sure that it's actually right. 4x times 1x would be 4x squared. 4x times 1 would give a group of 4x's. 1 times 1 would give a group of 1x's, and at the end 1 times 1 would also equal 1. Now what I do note with this is I could get a group of 4x's and 1x's to combine to be 3x's. The way that I would get that to happen, if I zoom in a little bit, the way that I would get that to happen, of course, is if the positive was in front of the 4x's, and that group of 1x would be negative, because 4x minus 1x would be 3x's. So if I wanted the 4 to be positive, the 4, where did this 4 come from? Well, it came from the 4x times the 1, which means that 1 must have been positive. And tracing back where I got this group of 1x's from, that came from right here, so I would need that to be negative. So my final answer, just summarizing, would be 4x minus 1 times 1x plus 1. Or you could just write it as x plus 1.